Good afternoon. We're going to go ahead and determine the cosecant of theta for a point that is graphed on a coordinate plane. It says suppose that theta is in standard position and the given point is on the terminal side of theta. So what I'm going to do is I'm going to go ahead and graph. The x and the y axis. And I know that this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And 1520 is going to be in quadrant 1. This is considered to be the terminal side, and this is the initial side, and this is called theta. So what I'm going to do is I'm going to go ahead and graph, and I'm going to make a right triangle. From here to here, that is the distance of y, and I know that I know x is equal to 15, and I know that y is equal to 20, so therefore the distance is 20, and I know in the x direction it's 15. As you can see, we have a right triangle, so we're going to have to find the hypotenuse at one point. So I'm going to go ahead and do that. So we're going to go ahead and use the Pythagorean theorem. So we have r squared is equal to a squared plus b squared. And we know that r squared is equal to 15 squared plus 20 squared. So r squared is equal to 625. So r is equal to the square root of 625. So the square root of 625 will be 25. Now it's asking us to find cosecant of theta, which is equal to 1 over the sine of theta. So I'm going to have to find the sine of theta and then get the reciprocal. That's what I'm having to do. So the sine of theta we know is going to be the opposite over the hypotenuse. And in this case, we have theta. Opposite of theta is 20. And then the hypotenuse is 25. And you notice that we can simplify by dividing the numerator and the denominator by 5. So we have 4 over 5. So if sine of theta is equal to 4 over 5, then cosecant theta will be the reciprocal, which is going to be 5 over 4. So your answer is C. For number 7, it's exactly the same type of problem. So what I'm going to do is I'm going to go ahead and draw the y-axis and the x-axis, and this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and we're looking for the tangent of theta. And if you know the ratio, it's going to be the opposite side over the adjacent. Tangent is opposite over adjacent. We know that 5, 3 will be in quadrant 1. Okay. So we know that the y distance will be 3, and we know that the x distance is 5. So what I'm going to do is I'm going to look for the tangent of theta. And like I said, the tangent of theta is the opposite of theta. So the opposite of theta is 3. The adjacent side is 5. So the tangent of theta, which is this angle here, will give you 3 over 5, that ratio. So the answer is A. Now for the last one, I'm going to go ahead and once again, it's the same process, but this time it's a little bit different. We know that this is the x-axis and this is the y-axis, and we know that we want to find the cotangent of theta, which will be 1 over the tangent of theta. So we're going to have to get the reciprocal of tangent to get cotangent. But you notice now we have negative 6, 3. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So negative 6, 3 is in this quadrant, which is quadrant 2. And I'm going to go ahead and I'm going to label the point negative 6, 3. And I'm going to make a right triangle. And I know that this will be negative 6. And I know the height is 3. And I know that this will be theta. So the tangent of theta is going to be the opposite over the adjacent. So the tangent of theta will be the opposite, which is 3 over negative 6. And we notice that we can simplify by 3. So we have by 3. So we have 1 over 2, negative 1/2. So the cotangent will be the reciprocal of tangent. So it will be 2 over negative 1, which gives you negative 2. Okay, so your answer will be D.